All right, hello everyone, this is Mr. Crozier. I'm going to help you with quiz review number 2. First off, product number 1, we're going to do it graphically. So if I need to find the derivative's value at -2, I come out here to -2 and I draw a tangent line. And that shows me that the slope is definitely going down. There's a point right there. And I usually look for another point. And in this case, I put a point down here. So this line is dropping at about 1, 2, 3 over 1. I did it earlier today and got -4, but it's just an estimation, so that's close enough. On f prime of -1, well, now I draw this line down here, and this line is dropping about 2. At 0, there is no slope. At 3/2, there is no slope. At 2, we're going to call this undefined because there's two possible lines here. Remember, it has to be the same value on both sides, and it's not. We have a derivative up here, we have a derivative there, it's undefined. At 3, well, this one we should all get right because this one, the slope is shown for you. It's a straight line. The slope there is definitely 1. At -4, I did a slope of about down 2 over 3. There is no slope here. At 1, if I draw this tangent line here, well, there's a point there, a good point to use. There's a good point there to use, about 3. G prime of -3, slope about -1. G prime of -6, well, we can assume that this line is going to continue downward because that's what the arrow says. So we can draw a slope there about 1 and about -4.8. There is no slope there. All right, down at the bottom, we're going to do 2 points down here to find our values. The first one we're going to do is the point 2. So if I plug in 2 here, let's see what happens if I plug in 2. So I have 3 times 2 squared minus 2. I have an output of 10. And then for my next point, I'm going to let delta x equal 0.01. So if I take 2 plus 0.01, now there is my new input. I'm going to find the slope between those 2 points, which are relatively close together. So now if I do 3 times 2.01 squared minus 2.01, there's my other output, 10.1103. And now what do? Well, I do y2 minus y1 over x2 minus x1. Subtract the y's, subtract the x's, divide. Same thing on all of them. Do the first point is 2, the second point is 2.01. This is 5 and 5.01. This is 3, then 3.01. Those are my 2 x values. Just be careful. If this had been -3, watch what happens if I have -3 and I add on 0.01. Well, now I'm at -2.99, so just be sure you're doing the right computation with the negatives. All right, on the back. Well, now we're going to analytically find all the derivatives. So we analytically find them. So I use the power rule. And now that I have this after the power rule, now I just plug in my -2 and do the math. There's the slope. We're finding slope graphically, numerically, and on the back we're doing it analytically. Analytically just means use all the derivative rules you know. On this one I'm going to change this to the 1/3 power, multiply the third down, subtract, and since this is a composite function, don't forget to add on the chain rule. You have to let u equal x squared minus 1, so u prime is 2x. On the next one, again, bring down the 3, subtract, leave it alone. Don't forget to do the chain rule. This is u is this inside, and this is u prime. On this one, well, we have a 3-step process. We take the natural log of the base, leave the middle alone, and put on the chain rule at the end. It's 1, 2, 3. Now I could have just done the math here, and the math would be, let's see what that is. That would be 5 to the 3rd power times 6. So it could have been 750 ln of 5. And then if I do that times ln of 5, we're there. So There are no directions for rounding, so just know either one here. All right, on the next one, well, this is left function, right function, left d right plus right d left. Now watch what happens if I do that. If I have the left function times left d right, that's 1 over x, plus the right function, which is ln of x, times d left, the derivative here is negative sine of x. So look what I did in two simplification cases here. This is cosine of x, 1 over x becomes this, and this negative changes that to a negative there. So it's left d right plus right d left, but then I simplified it. And then you just plug in 1, make sure you're in radians. On this one, standard quotient rule problem. Low d high minus high d low, simplify it down, plug in 0. Again, a 3-step process. And the 3-step process here is I have a natural log in the denominator, I have the argument itself in the denominator, and I have the u prime right there. So there's 3 parts. 1, 2, 3. You can do the math. Straightforward. Change this to 1/2. Multiply it down and get 4, subtract, and don't forget, since it's more than just x there, since it's a composite function, you have to add on the chain rule. Again, composite function, use the chain rule. You could let u equal x squared minus x, but you just put the chain rule in there. And again, here's that chain rule. Chain rule happens all the time. Well, not all the time, it happens a lot. If you have more than just x inside the function, chain rule. Where's one where we didn't need the chain rule? There was no chain rule up here because there's just x's. There's no chain rule in this one because there's just x's. It's just lefty right plus righty left. There's no chain rule in this one because it's low d high minus high d low. This is a quotient. This is a function in another function. Composite functions, quotients. All right, hope this helps for your quiz practice.